Hi everyone. This is a quick video that I'll do before I cut these shaded pole motor apart here. And I think this would be maybe interesting for the eccentric transformer topic. And I just decided to put my signal generator through these and just find out their resonating frequency. I bought these actually for doing another experiment. It has not necessarily related to the eccentric transformer topic, but I thought I'd do this video and post it there. And what I'm doing is I'm sending my signal generator, just the output of that, which is 10 volts RMS, and sending out square wave, and I have a 0.1 microfarad capacitor there in series on my negative line there, and my positive output of the signal generator is going through my amp and right now it is utilizing 11.87 milliamps on the AC scale. And I have my scope probe attached here on that coil. I'm kind of using it as a primary, and I have attached this other motor chassis, which you can see the rotors are gone. I took them apart, and I'm coupling them through magnets basically. So I got a magnet on this side here and a magnet on the other side there as well. And I've been playing around with magnets on them, and I see that I can actually get the phase alignment. I can change the phase alignment of this particular secondary here that I'm using by putting these magnets in different positions. So on the secondary here is coming out. I've got again my scope probe attached on it, and another capacitor there, but in parallel on that coil, and that's a 0.16 microfarad. Now I put a LED across it there too, and this is not anything extraordinary or anything like that, but I just thought, I'll share it, before I start cutting these things apart. And if we look at the scope shot, here in the green here, this big one is the primary, but here in the yellow here, this one is the secondary. And if you look at the primary, this is the period here where it's being shifted, the switching, and basically the secondary is exactly 90 degrees out of phase, I believe, with the switching happening. And so as this one is high, this one is low, and so on. So basically I think that when it's in this configuration, the load that's put on the secondary is not affecting the primary. And I can show you that. This is the data, by the way. We have 868 hertz, looks like. And because it's in resonance, it has a 70 volts peak to peak, and that's just from my 10 volts RMS input, and RMS voltage across the primer is 24 volts. The second there is the peak to peak on the secondary, 4.66, and about 1.69 volts RMS with that load. If I take the load off, it goes up to about 4 volts RMS with no loads. And what I've show you here, so we know that we've got 11.86 milliamps, okay, across of draw coming through here. Now, like I said, this is nothing exciting. It's not over unity or anything like that. But here I have this cable here, this alligator clip, and if I short that coil, okay, which I'll do right now, okay, we have a dead short. That should give maximum load on the secondary, which should affect the primary, right? And that's how normally transformer functions. But if we look at, our current, okay, again, it's not increasing in current. And if we look at our scope shot, well, our secondary is flat line here, and nothing is really changing on our primary. So I think that's kind of an interesting thing that could be looked at on the eccentric transformer work. And just thought I would share this one here. It's, like I say, nothing exciting. We're not putting out more power or anything like that. But what we are putting out is, obviously, here we got 11.83, and I'll pull off the alligator clip now. It's now removed. Absolutely no change. We're still at 11.83. Our lead is on. Alligator clip removed. I'll clip it back again. Shorted. 11.83. There's absolutely no change when, this is under load. So that's about it. Nothing exciting or anything like that, but I just thought I'd share this before I cut these things apart and that kind of thing. So I think it may be worth examining. Play around with magnets here. As you see, I've got a pole going across here on this magnet, on this secondary here coil, and I've got another magnet positioned here. I found that you move them around and you can see the phase kind of shifting, but you'll need an oscilloscope to be looking at the results so that you can get it tuned so that it's out of phase. Anyways, the output could possibly be increased as well. I don't think we would get 100% coupling through this method here, though. That's the other downfall. Anyways, just thought I'd share this just for the fun of it. Thanks for watching. Bye.